Hello, Michael Dennin here, and this is the Physics of X, where X is everything except politics. We've just wrapped up our Harry Dresden series. We might come back to that. There were some interesting things we missed, but we're going to transition over to a little bit of flight, propulsion, maybe some Star Wars spaceships, maybe some UFOs. I'm going to look for you to tell me what are your favorite spaceships. We can throw some of those in. But as always, make sure you like the video, subscribe, and ring the bell so you keep getting notified. Now, if we're going to talk about flight and propulsion, we have to start with the basics of how do you make things move. This is the really fun world of Newton's third law. Most everybody in the world has heard of every action has an equal and opposite reaction, and most of us really don't think about it much or actually completely understand what it means. At its basic level, it tells us when two things interact with each other through a force, each object feels an equal and opposite force from that interaction. That sounds very technical, but the really important thing about it is the fundamental way by which we make stuff move. The most basic operation of moving for humans is walking. Now, many of you might say, oh, that's easy. I know how to walk. I push on the floor with my feet and it makes me walk. Actually, that's not what makes you walk. If you think about it, when you push on the floor, you're pushing backwards. You're not actually making yourself move. The floor is making you move. That is Newton's third law. The floor pushes back on you, and it's the force of the floor on you that makes you move forward. This is pretty obvious if you've ever tried to move on ice or in roller skates, anything with wheels and not much friction. When you just push straight back, nothing happens because without friction, there's no force pushing you forward. If you think about skating, you're always putting your skates at a little bit of an angle to get that forward motion. This is basically, another way to look about it, conservation of momentum. Here's the funny part. When you move forward, the Earth is moving backwards. Now, momentum has to do with mass and speed. The Earth is a bit more massive than you, so you don't really notice it moving backwards when you walk. You just notice you moving forward. Why do I segue so smoothly to conservation of momentum? Well, that's the heart of propulsion, which is what we're going to get to with spaceships and the real interesting stuff. With spaceships, we're throwing stuff out the back, and that's why we move forward. The interaction that's happening is between the stuff and the part of our ship that's throwing it. So it's hard to think about the forces there, and that's why we like to talk about conservation of momentum. If you have the spaceship and whatever your fuel is, whether it's gases, jets, shoving air through your spaceship, whatever it is, you have stuff going out the back that at the initial moment was at rest. So you and the spaceship were at rest, you're not moving, that's zero momentum. If stuff's going out the back, the only way to still have zero is for you to move forward because those have opposite signs. We get to do some math with negative numbers and the two cancel and you still have zero momentum. So the two main lessons from today's video, if you want to walk forward when you push back on something, that is object you push on is what's pushing you forward, not you. And if you want to make your spaceship move, you throw stuff out the back and conservation of momentum makes you move forward. Now in our next video, we will actually talk a little bit about flight and we'll have to think about air friction and air resistance and what happens there. But for today, it's just the throwing stuff out the back or pushing backwards. And this has been the Physics of X. This has been the Physics of X, where X is everything but politics. Make sure you like, subscribe, and ring that bell so you get notifications of every episode coming weekly straight to you.